Please.
So welcome JP Oullette and Anna Lee Vienneau from NBPower and the GAIA Project, respectively. And so glad to have you with us on our first of 2021, Learning from the Land series, but second of the school year. So welcome aboard.
Thank you.
Thank you.
It's been great to participate in the previous presentations as well. So really happy for that a chance to listen and to learn this morning. So that's been quite refreshing. And just before we begin, I heard on the call earlier, I think it's Jackie's birthday somewhere. So happy birthday, Jackie. I don't know where you are, but I heard that through the grapevine. So just putting that out there. But I hope you all had a great lunch if you had time to, and we'll try not to bore you too much and keep you on your toes throughout this presentation. So here we go. We first want to acknowledge, of course, the GAIA Project recognizes and respectfully acknowledges that all of our educational interactions take place on the unsurrendered and unceded traditional lands of the Oullette and Mi'kmaq. And Stephen mentioned this before in previous presentations as well, so I'm happy he addressed a part of this. But this as you know, this territory is covered by the Treaties of Peace and Friendship, which the Oullette and Mi'kmaq and Passamaquoddy peoples first signed with the British Crown in 1725. So we want to pay respect to the elders, past and present, and descendants of this land. We honor the knowledge keepers, of course, and seek their guidance as we strive to develop closer relationships with Indigenous peoples of New Brunswick. So a little bit about ourselves. So my name is Anna Lee, and I work for the GAIA Project. So I'm working right now from my home, but I mean, I'm working on developing sustainable career project. And what that means is that we are trying to develop, to showcase green careers in classrooms all across the province. We're a provincial organization. So our main mission goal is to offer free project-based programs to classrooms from grade 3 to 12. French and English, and we support teachers in various different ways depending on the program that they do. But my project itself really is to kind of give students an idea of what green careers look like. What does that look like? What are some green career pathways? And then to eventually develop a mentorship program. So this project started a little bit before Christmas, and we'll be piloting 5 schools in April, May, and June to eventually have this program full on where teachers can access these resources as well. And that's also why JP is here, because I am no wind energy expert by far. I'm an educator, but I'm not, don't know the ins and outs of wind energy through NBPower, and I'll let JP, our expert, the connoisseur, introduce himself. JP?
Hello, everyone. JP Oullette here, product specialist with NBPower. I've been working in renewable energy programs for the last 8 or 9 years, and I was very happy to participate in the wind energy projects that the First Nations have been involved in and developing and put together here in the last few years. Notably the Oullette project in Residual I was intimately involved with in making that successful. So I'd like to thank you for the opportunity. NBPower is also a sponsor of the GAIA project itself, and it was a pleasure to help Anna Lee, which is very hard worker, I come to learn in the last couple of weeks, and was very helpful at putting this together, and she gladly volunteered to deliver this. So thank you very much, Anna Lee.
Good teamwork. We're good teamwork. So on the agenda today, we're going to talk about a few things. And this is not like the previous presentation, which I learned a lot from Megan and Megan, which was great on more details. This is more of a high level overview to better understand wind energy. So we're going to talk about the evolution of windmills, just a brief history. I'm not going to bore you too much, but just interesting facts mostly. We're going to look at where wind turbines are in New Brunswick, how they work. We're going to talk about electricity and technology, and we're going to finish with a Kahoot quiz. Woo! So, historically, there are different types of windmills used for different needs. So as you can see here in the image, so this is a ruin of a vertical axis windmill in Afghanistan. So windmills started when farmers in Persia, so Persia encompasses modern day today, Iran, Egypt, Turkey, and parts of Afghanistan and Pakistan and other places, but mainly those areas. So the first windmills were used to grind grain and pump water. That's the use. So of course, you know, wind has been around for a while now, but windmills have been used for these main two purposes. So you can see to the right image here. So the wind would hit these wooden panels and would turn, and they would put the grain underneath, so it would crush them, so it can make flour. So these little doors on the left image, that's where they went underneath to gather the flour and different grains. So that was just one little cool image I wanted to share with you. So wind power has been used through history, you know, for mariners, sailers on boats, rivers, lakes, and ships at sea as well. But today, the modern version of the windmill is the wind turbine. And of course, it looks way different than it did on the previous slide. So we're going to be talking more about wind turbines. So again, there's different uses, different needs, and it has evolved to what it is today. So modern towers are typically built from steel, as we saw previously in the previous presentation. They're transported in sections from the factory to the construction site by truck. I wish I would have had those images for this presentation. I might have to call Meg afterwards, say, hey, can you share those pictures with me? But they were really clear images of how they were built. So they're assembled a little bit like Lego blocks. So they're transported to the area that's defined for the project, and then they're slowly built up like Lego blocks, and they're typically built from composite materials like fiberglass and carbon fiber. So now, with this in mind, we know that wind is a renewable energy, but what does that mean? So here's a quick look. So renewable energy is often referred to as clean energy or green energy that we can hear also. So to your left here, so we have the solar, biomass energy, wind, which is what we're going to be talking about today, geothermal, and hydropower. So these renewable energies come from natural sources or processes that are constantly replenished. So renewable means that it continues to be available on Earth, and like wind, it's constantly produced. Versus non-renewable, non-renewable. So here to your right, we have fossil fuels, coals, natural gas, and nuclear. Means that it's a natural resource, but cannot be readily replaced by natural means or quick enough pace to keep up with our electricity consumption. So non-renewables only exist in limited supplies and can also cause pollution. But today, like I mentioned, we'll mainly focus on a renewable of the wind energy. So what is wind? You know, to better understand, again, just as the basic wind, when we talk about wind energy, what is defined as wind? So the first thing is air. So wind is air in motion, simply put, of course. And then it is produced by the uneven heating of the Earth's surface by the sun. And then to further that notion, since the Earth's surface is made of various land and water formations, as you can see, well, obviously this is a little cartoonish image, but it absorbs the sun's radiation unevenly, which makes wind. So the air is heated up at different land and water formations, and it absorbs the sun radiation unevenly. So there are two factors, and remember this, because this might be in the Kahoot quiz, I don't know, maybe. Two factors that are necessary to specify wind. We're going to be talking about speed and direction. Now that we have, you know, just the basic wind knowledge, let's see where the wind turbines are located in New Brunswick. So I was told that Southern Victoria High School was the whole school for these learning series. So I wanted to put you on the map here, just to give you a scope of where we are in New Brunswick. So let's see. We have Lamec Wind Farm up in the Acadian Peninsula. We have Caribou Project west of Bathurst. Then we have Oullette Residual Wind Project. We also have Capelé, Kent Hills Wind Farm. We have Wajausen Energy Project, which was the presentation before they talked about. And we have also Wisagalumsen. But for those living in Florenceville area, so Southern Victoria High School and schools around the place, you have probably seen or have driven by windmills, wind turbines already. So fun fact. So you see they're not on the map here in New Brunswick, and that's only because they're in the States. So the ones that we see driving up to, I'm originally from Edmundston. So when I go visit my family, you see them on the side of the highway. They're located in Mars Hill, Maine, which is still in Wabanaki territory, but it's in the main US side. So I mentioned of all of these here. So these are all the projects that exist currently in New Brunswick. And of course, with the one here in Maine, there's more than that in Maine, but I just wanted to showcase this one here. So I've named 3 First Nation wind projects, and let's go see specifically. So we have, like JP mentioned, who has worked with hand in hand, Oinpegajoig Rishubuktu, developed by Pabino First Nations and partnered with Natural Forces. And then we have Wajausen, which we just talked about as well, who was developed by First Nations, Tobic First Nations and partners. And we have down here the Wisagalumsen Energy Project, developed by Woodstock First Nations and partners. Let's see here. So now that we know the projects, where they are located, we want to know how many wind turbines are in each. And this might be part of a Kahoot as well. Hint, hint. So in Lamec, there's 30 wind turbines. And then we have in Caribou Project, there's 33. Oinpegajoig, there's 1. Capelé Wind, there's also 1. We have Kent Hills Farm that has 55 windmills all around. So this is actually, Kent Hills is the first wind farm developed in New Brunswick, and that was developed in December of 2008. And we have Wajausen, has 5 wind turbines, and also Wisagalumsen that has 5 as well. So that's brings us to a total of 130 wind turbines in New Brunswick so far. But why these locations? Why are they mostly on the coast here? Let's explore that just a little bit, just to see. So why in these regions? For proper locations, as was mentioned in the previous presentation, you know, it could be top of the hills, open fields, and for coastal winds. And when we talk about coastal winds, we're looking at good quality winds, a mix of constant speed. And I learned through developing this project and working with GP that I thought the more powerful the winds, the better for the wind turbines. But that's not the case, because that would be more damaging on the wind turbine at long term. So we don't want too harsh winds, but we want a constant wind is what we want, which is ideal for wind turbines. So we want constant in speed. We want also to be near to access a power grid, like was mentioned in the previous presentation, and also community interest and investment, of course. So it's all about balancing game, finding that perfect speed, a perfect location to be able to provide energy to the community. So how do wind turbines work? So the simplest way was with this visual is that the wind passes over the blades and makes them turn. So that becomes kinetic energy. And then secondly, the blades turn a shaft within the nacelle. And I think Meg mentioned earlier the nacelle. So this would be represented here in yellow or orange. So at the top of the box of the wind turbine. So that in itself, the shaft, will then turn a generator, which converts kinetic energy into electrical energy. So we see the wind comes in, turns the blades, and then the shaft generates and it goes down here to a transformer, which converts the electricity to the right voltage for the local network. And then whoop, goes out to electricity, is exported to the electric grid. So wind turbines work on a simple principle. Instead of using electricity to make wind, like fans that we have during the summer, wind turbines use wind to make electricity. Wind turns the propeller, like the blades of a turbine, around a rotor, which spins generator, which creates electricity. All of these together. And then we'll see here a little bit more detailed. So this is the nacelle we're talking about, and this is an image of someone in the nacelle with the gearbox. So this just gives you an idea of scale. So when they were painting the beautiful paintings earlier, it was on this little piece here. You can also see down here we have a little person in red too. It's just, again, to give you an idea of the scale. So the generator sits at the very top of that tower, driven by the blades, which are spun from the force of the wind. So generators are typically directly connected to a grid, and that means that the energy is used in that instant. So the instant the energy is created, it is used. The grid does not have any storage capabilities, so there's no possible way to store that energy. So when you see wind turbines turning, I mean, it's going to be producing electricity, and then it's going to be used right away. This is just another image to show you just of the scale of the person on top here. So they're pretty big. So here's a little bit of a scenario to give you a better understanding of how electricity gets to your door. So let's say you want to charge your cell phone, you want to take a hot shower, you want to cook a meal, or even flip on the switch to see where you're going in the middle of the night. So all of this goes through with the windmill, starts with the wind, like we said previously, and then converts eventually to your door. So we cannot, again, store energy, which means that we can have the right quality of wind that makes the wind turbine turn. The electricity that is produced is automatically used. Again, so it's an instant energy use that goes from rotating the energy, rotating that generator that converts wind into electricity. Then 2, that electricity goes through the transformer, as you see here, to increase the voltage for transmission. And then 3, the substation then increases the electricity voltage for transmission over long distances. So we need to pump it up so we would get enough energy to get to your door. And then 4, transmission of electricity to distribution companies like NBPower, where JP works. So the question remains, again, why do some wind turbines produce less or more electricity than others? Why do some of them are able to help with electricity for maybe 900 homes versus another one that can produce electricity for 1,000 homes? Let's go see. So some of you might remember, some of you might not, depending on the era you were raised in, but the image to the left is a flip phone, which is back then when flip phones, I mean, they still exist now, no judgment, but it was great. I mean, they were great for what they were. The technology then was amazing, but then came, a newer technology, a better, efficient, and this is for Android as well, or Apple. So we're talking about old and new technology. So like cell phones, wind generation technology is improving at a fast pace. So simply put, newer models of wind turbines are more efficient than older ones. So when we talk about older wind turbines, they can produce even about half the energy that can produce a new one now. We're going to go see a little bit more about that. So in old and new technology, today, so one wind turbine can produce approximately 4.2 megawatts of electricity, average in a year. So a lot of the wind turbines that we have in New Brunswick are newer models. So large generators produce a good amount of electricity, But what does that look like? So what does one wind turbine that produces 4.2 megawatts, what does that look like in number of homes? So that means it can power up to an average in a year. One wind turbine alone can power 1,000, on average, 1,000 homes. Again, this all depends on consumer needs. Some houses will need more energy than others, depending on habits, efficiency in housing and appliances. All of that come into the mix. It's not a straightforward math equation either, but it all depends on how much we consume, how we consume it, and then also the wind, the quality of the wind that comes in the wind turbine. So this is just to give us an idea of scale on see different wind turbines that produce different amounts of electricity. So I don't know if you can see here, it's very, very small. There's a house here. And to our left, there's actually a small little person, just to give you an idea of the scale. And of course, you've probably seen wind turbines before, but what's interesting is there's different wind turbines, there's different sizes for different needs. So I just wanted to see, so we start here at the house, and then we have a household wind turbine that can produce 10 kilowatts, and then we go bigger and bigger and bigger, and the bigger we go, the more electricity we will have. So that one windmill that produces 4.2 kilowatts or megawatts, pardon, will be a lot bigger than this one here on the image. So that's just the scale to better understand, you know, when we're talking about wind energy projects, we'll usually see bigger ones that'll produce more energy. Let me see here. So just to give us an idea of how much electricity is produced at each wind farm or wind project in New Brunswick. So the Kent Hills farm, which has the most wind turbines, we're looking at 167.3 megawatts, and then Caribou 99 and Lamec 45, Oullette 18, Wajausen 20, and then we have Oullette 3.8, and then Capelé 2.35. So really the difference between these two, because it's the same numbers, you see here that Oullette and Wajausen both have 5 wind turbines, but produce different amount of electricity. And that is simply explained by the old and newer technology that is in place there right now. So I feel like, JP, is there anything that I'm missing? I feel like I talked through that pretty fast, and I hope I didn't miss anything. Just want to check in.
No, I think you did an awesome job, Annalie. I think the one thing that that's important to understand is these sources like wind and other renewable sources like solar and others are intermittent sources. And Annalie stressed in the previous slide that electricity needs to be used at the moment it gets produced virtually. So even with these wind sources or these solar sources or other renewable sources, there remains that, you know, the electric utility needs to provide you that electricity at the moment it gets produced. So you always have another type of generation in the background here, kind of backing up these sources when they're required. And I think part of the future is, how do we integrate more of these on the grid while having the backup in order to maintain the electricity that we require as a society? So it's a little bit like a band playing music. You know, everything needs to be synchronized and happen in tempo and happen at the same time in order for this to be successful. So that would be my addition to this, Annalie, but you did an awesome job.
Thanks, Chief. Again, we're tag teaming here. So this is what we had to offer today for wind energy, demystifying wind energy. We also, before we head into the Kahoot quiz, want to thank everyone, you know, Waliwan, Walalan, merci for everyone who's attended and who's interested by this. So now we are going to jump into the Kahoot quiz. And Callie, if I stop sharing my slide, is that correct? Is that how we're doing it?
Yes, I can run it. Yes, here. Just,
Awesome. Thank you.
no problem. Just give me one moment.
We might get less Kahoot participants than this morning, which was over, I don't know how many, which was it, like 50 something people participated?
Yes, I think it was 54.
Amazing.
Can everyone see my screen?
Yes.
Awesome. Okay, so for those of you who haven't played Kahoot before, you can join at www.kahoot.it on your browser, either on your computer or mobile device, or you can join on the Kahoot app. You join by entering this pin here. There's no space. And once we have everyone, I will hit start and I will let you navigate it, and I'll be your cursor.
Sure. Perfect. Thank you.
No problem.
Winbird, you're going to be on the spot. You better get all of these right. I'm teasing. We might, if you're okay with it, we might just kind of just go see, it's kind of like a little review of the presentation of just key
Perfect.
points and just, yeah, that's okay.
And if anyone would like to jump on as we're going, I believe it stays up as we're playing, so you can still enter.
So what were windmills originally used for? It's hard not giving the answer. It's true. I think it was Sheldon who said it this morning.
Yes.
So grinding grain. So that was one of them for sure. And there was also, we talked about water pumps, but that was the main one, was grinding grains. Well done. Number 2. Renewables mean that it will continue to be available on Earth since wind is constantly produced. True or false? So we talked about renewables and non-renewables. So the answer is true. So we have renewables, I mean, they'll continue to be on Earth, and wind is constantly produced. So that's a renewable energy. So what are the 2 factors necessary to specify wind? Is it heat and speed, heat and direction, speed and direction, or none of these at all? Speed and direction, well done. Those are the 2 factors necessary. How many wind turbines are in the New Brunswick today? So what's the total of wind turbines? Are we looking at 10, 130, 77, or 250? 130 wind turbines, and possibly more eventually, depending on how many projects are being developed. But right now, 130. Oh, sorry, you can go ahead.
Okay. Just want to let you talk as much as you need.
Can wind energy be stored to use at a later time? Yes or no?
That's a little bit of a trick question, Annalie.
I know. I did it on purpose. So wind energy cannot be stored. So good answers, everyone. And last question. On average, how many houses can one wind turbine, so one that produces 4.2 megawatts, power during a year? Is it 50, 500, 1,000, or 5,000? A 1,000. Well done. So one wind turbine at 4.2 can power up to 1,000 homes in a year. And that's it for us. Woohoo! And then number one is
A mystery.
star, 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 star. Congratulations. Thanks for participating. I don't know if we had time for questions, Pamela, if that's, or, because I know.
We do.
Okay.
People want to fire questions into the chat or just blurt out. We do have time. I'll just keep the recording going, and I have to comment on your background. It's like you synchronized your slides with your wall. Whether you did that intentionally or not, but it was very pretty.
When I started working at GAIA, I decided to paint my wall just to make sure it matched. I'm kidding, not true. It's just a great coincidence.
I love the idea of stressing that backup, just knowing that we have to have sources from all areas. And I keep thinking of our friends in Texas who shut down coal plants, and then their wind turbines froze up, and they have just been in a pickle because of climate that wasn't expected when they built their farms. Gas prices or electricity prices have just gone through the roof south of the border.
I either did a really good job, if no one has any questions, or everyone's asleep, either or. So I think
No.
I'll go with the first one. I'm kidding.
You should. You're a born educator. There's Bernie.
I'll fire a question. JP, when you asked the question of what energy being stored, he said it was a tricky question. My understanding is if you have an alternator, you can store it in batteries for later use. Is that correct?
Of course, yes. There are some energy storage options, but commercial level energy storage is seen today as not commercially viable for this moment in time. We're getting close. Our integrated resource plan at New Brunswick Power shows that it's cheaper to build capacity right now than to integrate storage. Battery prices are coming down. And there are some technologies out there in the southern parts of other areas, for example, there are places where they have mines where they compress air. So they close the cells up and they seal them up. And when they have excess capacity from wind generators or that, they run air compressors or air blowers and they compress air into these mine shafts. And when then energy is not needed, that wind blower is actually you move air back out of those blowers and put that electricity back onto the grid. So there are several types of energy storage technologies out there, depending on what the application is, capacities, and so on and so forth.
And is the same principle, does the same principle apply to solar?
Absolutely. Yes.
Okay,
In a lot of solar areas, especially along the coast areas, what they'll do is they'll pump water. So they'll pump water behind a barrier, and as soon as a low tide goes out and they need electricity at that moment in time, they let the water out and they use hydro water. So they pump
it
water
becomes
behind
hydro.
the barrier, and then they let hydro run out. So it's a way of using excess energy, and that's part of the puzzle of integrating renewables onto the grid.
Yeah, no, excellent. Thank you.
You're welcome. There's usually one person that stumps me really, really well when I do one of these
It won't
sessions,
be
and
me.
I'm waiting for that question. So please, I like it when somebody stumps me, so it makes me go do research.
I've heard, and maybe you can demystify this, Annalie or JP, that some have experienced stress from the humming and the continual sound of the turbine going, that it's affected breeding patterns in wildlife, particularly dog breeders in an area close to me. I've heard this. I haven't spoken to the breeder, but can you speak to that residual hum that they generate and maybe demystify?
And Lee, did you want to take that one, or I always
All
get
you,
late.
JP.
Okay. Yeah, so that has been expressed in all through the world with wind generation, where either the mechanical hum or the hiss from the wind rolling over the turbine blades cause effect. In some cases, it's vibrations coming out through the ground because these wind generators are very, very large, and they are on a really large concrete base, usually sitting on bedrock. And there has been some stories of people being affected by vibrational areas, not necessarily close by, but could be several kilometers away. And studies have shown that it's no more a deterrent than any other audible sound that would be affecting you. Just like I can't sleep on an airplane, and I can't sleep in a car for the same reason. That ambient constant noise just keeps me awake. And I think that it has that little bit of an effect on people. And I think that's where you're going. So I wanted to answer it in that way, Pamela.
Great, thank you. I grew up on the Trans-Canada and never bothered by the transports growing up, but guests would be. So yeah, great point.
And me neither. I grew away 700 feet from the Trans-Canada Highway up in the Edmundston area, and I, like you, windows wide open in the middle of summer, and transport never bothered me or anything. Jake brakes or never bothered me or anything like that. But that constant noise of being there all the time. For a couple of years before I joined NBPower, I was a trucker, and I slept in the truck sleeper in the wintertime. So you had to leave the truck run, and it was an awful few days for me when I had to sleep in the truck because it was terrible. It was terrible because I couldn't sleep. Anyways, I'll leave it at that.
We have a couple of questions in the chat. What kind of jobs could be available to maintain the turbines? That's coming from Tobik, and I'll read the second one and you can tag team. I missed part of the presentation, so sorry about this. How do you recycle these huge wind turbines once their life is over? With all the non-renewable materials that go into creating a turbine and its base, how much more green are they? And that comes from, I don't know where, from a guest in the audience.
So Annalie, if I may answer the first one. So trades around the maintenance and operation of these turbines is something that's upcoming in our area of the world, Canada, the United States. And absolutely, I mean, these companies need mechanics. They need electrical people with electrical and control knowledge. They need people that understand weather. because weather impact the operation of these turbines. Every single one of these turbines has a weather station on top of it. So you need to understand the science behind all this and being kind of a little bit of a jack of all trades when you're working on this stuff, right? And on the control side, it's very important to have some engineering, electrical engineering qualifications, some mechanical engineering qualifications. As we integrate more of this on the renewables on the grid, it's understanding the impacts on the grid system. So NBPower is working on a smart grid objective where we need some specialized trades that are not yet developed in order to integrate all these little pieces of the puzzle together. You know, electrical engineering understands part of it, mechanical engineer understands part of it, but there's nobody that understands that whole complex infrastructure as one. So trades are very important as being a part of this. So any mechanical trade, any electrical trade would definitely benefit from that. And Annalie, I don't know if you wanted to take the second one, but I can answer it if you want to.
You're on a good roll there, JP. I'm going to let you
Okay.
continue.
So recycling of these large devices at end of life or when a part breaks is important. In the history, we always looked at, is it cheaper for us to throw it away than to break it up and recycle it? So the composite material around the blades has always been a concern around manufacturers, from manufacturers on being able to recycle these parts. And they're finding ways to recycle the fiberglass and the carbon fiber and the other composite materials used in these turbines in order to cut them up, shred them up, and reuse them in the manufacturing and use of new systems. When it comes to the electrical and the steel of it, well, we all know that that can be cut up, crushed, and recycled just like anything else, right? But in our environment and the way we treat Mother Nature, I think we always value the dollar before valuing Mother Nature. And I think as a society, we need to change that. We need to look at that metal and seeing that that's as valuable, crushing it and recycling it into a new device that's going to have a whole new life instead of throwing it away. And that's my simple answer to that.
Great. I can certainly appreciate over time how impact assessments have changed too on all these projects, and the thickness of the assessments and the time it takes to get to the construction point is appreciated.
And Pamela, if I may add another kind of view, and Annalie and this, we discussed this, we went back and forth on this when we were putting the presentation together, is that if I present you and Pamela and say, Pamela, we need to install a power generator in your backyard or, you know, in your community, and we have this coal plant with a boiler, and we're going to have trucks of coal coming in on a daily basis. We're going to haul ash on a daily basis. We're going to have a wastewater plant that's going to be part of that because we need to boil water to create steam and all the pieces that put that to it. Or we can install a few windmills in your backyard. For me, as somebody that's been working in the industry for a long time, my choices would be quite clear, right, on which one I would pick. So sometimes, because as consumers, we are the ones that are driving the energy requirement.
Mm-hmm.
It's not the utility. The utility has been there mandated to be able to provide it to the consumer. So as consumers, if we can manage and be efficient at the energy use we use, the less amount of effect on the environment we will have, whether it's a windmill, a solar panel, or a coal plant, or a nuclear plant. At the end of the day, if the customer wants that energy, it needs to be delivered to them.
We could talk for a long time. I'd love to hear an energy comparison from, how many turbines would it take to equal a dam and the size of a hydroelectric dam, and are they replaceable? Are they equivalent? Could the demand on one be lowered, so that there's less impact on a river or, you know.
Yeah, and like I mentioned earlier, all these different technologies and devices need to work as a symphony, more or less,
Yeah.
in order to deliver the electricity to the customer. So it's not only the generator, but it's also the wires, it's also the people, it's also the trucks, it's also the buildings, it's also everything that needs to support that whole infrastructure that has an impact on what we do, right?
Super. Well, I want to thank you both on behalf of all of us in Zoom land and the students who are, you know, multiplied behind one screen of a teacher. Thank you so much. I look forward to having you back tomorrow and generating some more questions, no pun intended. In other parts of the world, you can purchase clean energy versus conventional energy. Yes, I know. I've had exchange students that are perplexed that we can't choose where our energy comes from. Is NBPower thinking of doing something like this in the future? And I'll leave that as the final, I promise, the final question, and we'll give you all a break before our next guest.
Yes. So NBPower today produces about 44% of their energy on an annual basis from renewable sources. Okay. If you look at the non-emitting part of it, non-emitting, so non-carbon emitting sources of electricity, we're up at the 80% mark. I don't think there's any other jurisdiction in Canada, maybe outside of Quebec and British Columbia, that can claim that as non-emitting or renewable. So we're doing really, really well in New Brunswick. Adding renewables and getting to 100% renewables is a goal, but there's a mandate that needs to be there that we need to procure energy at the least expensive amount in order to make sure that we don't put extra pressure on our ratepayers. There's a great amount of people in New Brunswick that cannot afford their bills today. So it's always a balance between doing the right thing on this hand and doing the right thing on the other. Because as a society, we need to keep moving forward. People need to be able to pay their bills. We need to take care of Mother Nature as well. So how do you balance one? It's easy to argue one side or the other, but when you're stricken with finding that balance, it's a hard decision to do. So
thank you guys. Walalen et merci bien.